So here we're given a fairly simple circuit, not as simple as some of the others we've seen, but here we're asked to come up with the nodal equations. We're not asked to solve them, just to derive them, and they want us to do it in a way such that we can determine the shown node voltages. And so they've identified 4 nodes of interest. So the first one is V1, next one is V2, next we have V3, and finally we have V4. So if we start with our nodal analysis here, we'll start with V1, which is the red node. And as we come around here, we see we have 2, and notice these are in Siemens, not in ohms, so it's conductivity, not resistivity. So that being the case, we just multiply instead of divide when we apply Ohm's law. So this then will be 2V1, and as we move around to the 14, then that one will be plus 14 times the difference in the voltages, so V1 minus V2. Again, we're just going to get all the resistances first. So next, we will come around to this guy, and so that one is going to be 1 times the difference in V1 minus V3. And then finally, we have the 7 Siemens component, and that one is going to be 7 times V1 minus V4. Now to go back and pick up the current sources, we have this guy here in blue. Oh, excuse me, that one doesn't go into our node. We have this one, the 4 amp. That's leaving our node, so we define leaving as positive, and so that's going to be a plus 4. And then we also have this guy here coming into our node, and so that's entering the node, so it's going to be negative. So that'll be minus 7. And that appears to be everything going in and out of our node. So next we will go to V2, which we've designated as blue. So the first thing we see is the green resistor, and so that's 14 times V2 minus V1. Again, just the differences in voltages. Next, we're going to have this guy, the 6, and so that one's simple enough. That's just 6 times V2 because it goes to ground. And then the next one we want to look at will be this 5. And so that's going to be 5 times V2 minus V3, the difference in the voltages again. And so then all we're left with is this current source right here coming into our node. So that means it'll be negative. So then that would be minus 11. And so again, that's all the nodes, or all the branches coming in and out of our node. So we can set that equal to 0, just as we could do that one. So next, moving on to V3, which we've designated as green. First thing we see is the purple resistor, and so that'll be 5 times V3 minus V2. Next, we see this guy, the 3, and so that one will be plus 3 times V3 because it just goes to ground. We look for the next one. We have this resistor that's connected to our node, and so this one will be plus, hold on here. There we go. Plus 8 times the difference in the voltages again, so it's V3 minus V4. And I think that's all the resistors we see for V3. So we've got the 5, the 3, the 8. Oh, we do have the 1 in blue. So we have the 1 ohm resistor, and that's going to be V3 minus V1. So that's this guy here. And then that should be all the resistors connected to our node. Next, we want to catch the current sources. So we see we already have the blue one next to the resistor we just did, and that's 4, and that's coming into our node, so that'll be negative. And then we have the 12, which we will show, or we'll do the 8. Let's do the 8. So the 8's leaving our node, so that's positive. So that's plus 8. And then finally we have the 12. And the 12 is entering our node, so it's negative, so minus 12. And 1, 2, 3 current sources is all I see coming in and out of that node. And we've caught all the resistors, so therefore this should equal to 0. So finally we move on to node 4, which we designated as purple. So here we've got 2 red resistors. We've got an 8 and a 7, so we'll just write them both real quickly. So the 8 is going to be 8 times V4 minus V3, difference in the voltages. And then we have the 7, which will be V4 minus V1, the difference in those voltages. And then we will have this 9 Siemens resistor. And so that's going to be plus 9 times V4, because it just goes to ground. And so that's all the resistances. So now we need to catch the current sources. So again, we have 2 of them in red. We have the 8 amp, which is coming into our node, so that means it's negative. We have the 7 amp, which is leaving our node, so it's positive. And then finally, we'll have the 9 amp in blue, and so it's leaving, so it's positive, so plus 9. And these should all equal to 0. And so there's how we construct our equation. So now we can reduce everything and get, gather up like terms. So we want to do that for these 4 equations. So I'll rewrite those up here. So first, we'll do the red node, or V1, and what it'll reduce down to is 24 V1 minus 14 V2 minus V3 minus 7 V4, and that's all equal to 3. So next we will have V2, which was blue, and that one reduces down to minus 14 V1 plus 25 V2 minus 5 V3, and that's going to equal to 11. So there was no V4 component there. Next we'll go to V3, which we designated as green. And so for this one, we'll have minus V1 minus 5 V2 plus 17 V3 minus 8 V4, and that's going to be all equal to 8. And then finally, we've got V4, which we designated as the purple node. That is minus 7 V1 minus 8 V3. There is no V2 component. And then plus 24 V4. And that's going to all equal to minus 8. So this is what they asked for. 4 equations, 4 unknowns, system of equations to solve for the voltage at those 4 nodes. So from this point on, it's just a linear algebra problem. So we should be able just to plug this into our calculator, or if you wanted to use some other matrices operators, you can solve for the 4 voltages there. But we weren't asked to do that. We were just asked to come up with the equations. So that's them.